Hey everybody, it's Brian with Radical Prep. Welcome back. We're working on practice test number 1 for the new SAT. And we're on question 21. The data in the table above were produced by a sleep researcher studying the number of dreams people recall when asked to record the dreams for 1 week, or their dreams for 1 week. Group X consisted of 100 people who observed early bedtimes, and Group Y consisted of 100 people who observed later bedtimes. If a person is chosen at random from those who recalled at least one dream, what is the probability that the person belonged to Group Y? So what the heck are we looking for? I like to kind of focus in on that at the end of this paragraph here. We're looking for what is the probability that the person belonged to Group Y. So we're looking for Group Y people out of all the people who recalled one dream. Okay. So we have to look at all the people who had at least one dream. So that is all this information here, from here to here. 1 to 4, 5 or more. We're not looking at people who had no dreams. So how many people is that? Well, that's just going to be 39 plus 125, right? It's coming from both groups. So that's going to be our denominator. 39 plus 125, which equals 169. No, 164. Sorry, 164. Well, already I'm looking at. It looks like choice C is going to be the right answer. And let's just look at the numerator. How many of them were from Group Y? Well, Group Y had 11 people, just specifically Group Y. 11 people plus 68 people, which is 79. All right, that's all you got to do. The hard part is understanding what the heck they're actually looking for. That's it, number 21. Let's move on. Number 22. All right, well, I'm going to move down just so I can see the question here first. 22. Which of the following best approximates the average rate of change in the annual budget for agriculture and natural resources in Kansas from 2008 to 2010? So agriculture and natural resources we're looking at 2008 all the way to 2010. And basically we're looking at a change of 488,106 minus 358,708. That's a 7. All right, so let's first figure out what was the change in those years. So I'll do that quick on the calculator. 488, 106 minus 358, 708. We're looking at 129,000. So let's just round it to 130,000. All right, so again, we're just rounding here to 130,000. And how many years is that over? We went from 2008 to 2009. 2009 to 2010, we're dividing by 2 years, so it's about 65,000 per year. Okay, let's just make sure that we're answering the question. The rate of change from 2008 to 2010, yeah, that's pretty straightforward. You just want to know change over the amount of years. That's all you're finding. Choice B. All right, let's look at the next one, which is still related to the data. Which of the following, which program's ratio of its 2007 budget to its 2010 budget is closest to the human resources program ratio of its 2007 budget? All right, so they're basically saying, hold on, 2007 to 2010 is closest to the human resources budget. All right, so let's go back up. The ratio, human resources, so that's right there. Human resources, 2007 to 2010. So you're basically looking at 4,051,050 to 5,921,379. So let's get a ratio here. 405,1050 divided by 5,921,379. We're looking at 68.6841. 0.6841, And if we had to make that the closest fraction near there, 0.66, let's just say 0.66 is 2/3. So the ratio from 2007 to 2010 is about 2/3. We need to find another one that's about 2/3. All right, so keep that number in your head, 2/3. Of the following, which program's ratio is closest to 2/3? So let's look at agriculture and natural resources. Agriculture and natural resources, we're looking at 373, 373 over 488. So I'm gonna try and avoid doing the math here. So we got 3 something over high 4 something. So this is about 3/4. Not really what we're looking for. Let's go to the next one. Education. All right, so education says, sorry, keep hitting buttons here. Education goes from 2 million to 3 million. Well, that's pretty straightforward. And honestly, I'm going to pick that answer because I got to save time. And it's just a little bit over 2 million. So we're looking at 2 and change over 3 and change, 2/3. I'm going with education. That's it. I'm not going to waste time on anything else. All right, number 24. Which of the following is an equation of a circle in the xy plane with center 0, 4 and a radius with endpoint 4/3, 5? Okay, so to do a question like this, you got to know what is the equation of a circle. So we've got the x minus this is the x value of the center point, squared, plus y minus, and here's just the y value. I'm not going to write the whole thing out, but it's the y value of the center point, blah, 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 blah. That just means all that stuff I just wrote, equals the radius squared. So let's plug in some information here. X minus, well, it's x minus 0 squared. So that's just x squared. Plus y minus, what's the y value of the center of 4? Y minus 4 squared, right? So that means that this is gone and this is gone because those are pluses. Okay, equals the radius squared. Well, the question is, how do I get the radius? Well, the radius is really just the distance. And it's the distance from the center to some endpoint. So I'm going to use the distance formula to figure out the radius. Okay, so the distance formula is distance formula equals radical, and I'm not going to use the radical, you'll see why in a second, but it's radical x2 minus x1 squared plus y2 minus y1 squared, right? So let's just plug in to find the distance from here to here. We're just plugging in points. So the x's, it's going to be 4/3 minus 0. So that's just going to be 4/3 squared. What is the y's? 5 minus 4. So that's just 1. That's 1 squared. I'm just trying to save a little bit of time here. So 4/3 squared, 4/3 squared is 16/9. 16/9 plus 1. Well, instead of writing 1, I'm going to write 9 all over 9. Because that is the same thing as 1, right? So that is 25/9. So the distance, or the radius, really, because from the center to an endpoint is just the radius, is radical 25/9. But in the equation of a circle, we're actually looking for the radius squared. So if distance from, or the radius really from here to here, if that's radical 25/9, to get the radius squared, we just get rid of the radical sign. I hope that made sense. You're finding the distance, or the radius here, and our distance formula gave us radical 25/9, but in our circle formula, you're looking for r squared. So it's just 25/9, choice A. Okay, that's it. All right, number 25. This one says the equation above expresses the approximate height h in meters of a ball t seconds after it is launched vertically upward from the ground with an initial velocity of 25 meters per second. So that's in the equation there. After approximately how many seconds will the ball hit the ground? Okay, So what does it mean for the ball to hit the ground? What is the height? It's basically saying they want to know when is the height 0. So if you put that into the equation, you get 0 equals negative 4.9 t squared plus 25t. So how do you get something 0? Well, this part of the equation plus this part of the equation have to cancel out, don't they? So this one should be about the same as this one. So why am I telling you that? When I think about that, let's say I plugged in answers. Let's say I thought A was right. 3.5 times 25. All right, 3.5 times 25 gives you 87. Well, 3.5 squared is like 4, or close to 4. So 4 squared is 16. 16 times 5, all right, is only going to be about 80. And that's on the high end because we rounded 3.5 up. So this number is not going to work. But let's just look what happens if we kind of thought about this rationally. Let's go to the opposite end. Let's look at D. What's 25 times 5? Well, I don't know, but let's just leave it. Here's negative 4.9, which is pretty much 5. What is 5 squared? Well, 5 squared is 25. So look what happened here. We have negative almost 5 times 25 plus 25 times 5. That's going to be basically 0. And the reason that we don't need an exact answer for this question is because it said approximately how many seconds will it take for the ball. So about 5 seconds. So this is kind of the way I thought about this problem. You're looking for the left side and the right side of that equation to cancel out. All right, choice D. Number 26. 26. Katerina is a botanist studying the production of pears by 2 types of pear trees. She noticed that type A tree produced 20% more pears than type B trees did. Based on Katerina's observation, if type A trees produced 144 pears, how many did type B produce? All right, so it looks like we have a ratio problem here. So type A produced 20% more pears than type B. So if type B makes X amount, type A will do 20% more, so you just write 1.2x. It's always the 1 plus the percentage. Based on Katerina's observation, if type A produced 144, so I can just write 1.2x equals 144, divide by 1.2, divide by 1.2, x equals 144 divided by 1.2 gives me 120. So x is 120. That's it, you're done. Move on. All right, number 27. A square field measures 10 meters by 10 meters. 10 students each mark off a randomly selected region of the field. Each region is square and has side lengths of 1 meter, and no 2 regions overlap. The students count the earthworms contained in the soil to a depth of 5 centimeters beneath the ground surface in each region. The results are shown in the graph below. All right, so kids are picking out little sections of the field. They're digging 5 centimeters down, and they're finding so many amounts of earthworms. So what I would want to picture in my head, though, if I would kind of draw this out to get a better idea, if you had your big field like this, right, let's just pretend that's a 10 by 10. There's 10 meters, and there's 10 meters. What's actually going on? They're picking out these little squares, and they're finding out how many earthworms are there, right? So each one of these is 1 by 1. So if the entire field is, was it 100 meters squared, and then I'll say each sample, we'll call each one of these a sample. These little squares here where each kid is digging is 1 meter squared. Whatever they find in here, to get the amount in the entire field, they should multiply by 100, right? Because this is 1/100th of the total size. So if we look at all our scores here, or all our number of earthworms, what's the average? Well, I'm not going to sit here and add them all up on test day because that's a waste of time. But look at our answers. It looks like it's 1,500 or something like that. So if we look at all our scores here, let's just assume that whenever someone digs, they bring up about 150 earthworms in each one of these little patches. I'd say that's fair. So if each one of these little patches brings up 150 earthworms, if we want to figure out how many are in the entire field, we're going to multiply that by 100. So 150 times 100 is just 2 decimal places over. That's 15,000. Choice C. Hope you guys understood the logic of that, because if each little patch has 150 earthworms about, and those patches make up 1/100th of the field, the total amount of earthworms is just going to be 100 times whatever that little sample reveals. All right, that's it. Okay, number 28. If the system of inequalities y is greater than or equal to 2x plus 1 and y is greater than 1/2 x minus 1 is graphed in the xy plane above, which quadrant contains no solutions to the system? All right, I kind of like that question. So let's graph the first one. Y is greater than 2x plus 1. Well, if we just put our little dots in here, how do you graph 2x plus 1? There's the y-intercept. Up 2 over 1. Down 2, left 1. Down 2, so your left 1. So your first line kind of looks something like that. And it wants all the y's greater than. So that's going to be all that stuff. Okay, 1/2 x minus 1. There's minus 1. And this is 1/2 x. Y is greater than. So this is up 1 over 2. Up 1 over 2. So now you got a line that's looking something like this. Right? Sorry, let me get it a little better like that. And they want everything that's also above that. So that's okay. Which quadrant has no solution to the system? Well, it should be pretty apparent at this point that nothing ever hits quadrant 4. Right? It's going to hit here, it's going to hit there, it'll even hit in quadrant 1 really far up. If the graph was bigger, you'd see it over there. So, yeah, that's it. All right, number 29. For a polynomial p of x, the value of p of 3 is equal to -2. Which of the following must be true about p of x? And I find this one kind of hard to explain. I was taking a look at it for a second before. Well, first thing I'm going to do is I'm going to draw a graph. And we got an xy plane. And what does it mean? What's that notation, p of 3? That means when the x value is 3, I get a y value of -2. So when the x value is 3, my y value is -2. So that's a point here. We don't know what this graph looks like though. So hypothetically, it could look like, that. It doesn't really matter. We don't know. The only thing we know is that this point is here. So x minus 5 is a factor of p of x. So what does it mean to be a factor? Factor means root. Okay? Factor means root. Okay. So that means that x equals 5, even though it says x minus 5, 5 would be the root here. Right? But we don't know that from our graph. I could have drawn the graph like that and had it go through here. Right? But I don't know if 5 is a root. How do I guarantee that? I can't guarantee that. And this is going to be one of those questions that I really give you the answer by process of elimination, because I don't really have a good explanation as to D, and I'd love for one of you guys to give me a nice easy explanation if you can. But let's get back to the answers. X minus 2 is a factor of this. So x minus 2, it means that 2 would be a factor, or 2 would be a root. So that means I'm assuming it goes through here. But do I know that? How would I know that? I don't know that. All right, because I could have drawn the graph like, maybe that, and had it go back down through there. Right? So I don't know that. And it's the same reason I'm going to get rid of choice C. X plus 2 is a factor. This means that -2 would be a root or a factor. So I drew it like this. I could have drawn the graph like that, but I don't know how this graph behaves. So I can't pick A, B, or C. By process of elimination, this is the only one I have to pick. And I'm sorry I can't give you a better answer. Maybe you guys can help me out and give me an answer for why D is correct, not by eliminating the other 3. All right? Let's move on to the next one, because sometimes that's how you're going to have to get answers on this test. You may not know exactly why something's right, but you know the other ones are crappy. All right, number 30. Which of the following is an equivalent form of the equation of the graph shown in the xy plane above, from which the coordinates of vertex A can be identified as constants in the equation? So there's vertex A. I don't exactly know what it is, but let's look at our answer choices here. Oh, and here's the equation. So the vertex looks like it's at 1, maybe 1, -16, or 1, -15.5, something like that. And it wants to know from which coordinates of vertex A can be identified as the constants of the equation. Well, if I had no idea how to do this, I don't see a vertex. Remember, my vertex is here. There's nothing in here that has to talk about 1 and -16, or 1 and -15.5, somewhere around there. D's the only one that actually does that, and it turns out D's the answer. Now, how do you do this the technical way if you want to get it right on test day? Here's the equation of, let me just get rid of everything. Here's your equation of the parabola. So watch what you're going to do. You remember completing the square? So we got x squared minus 2x minus 15. So I'm going to take this part on the left here, x squared minus 2x. I take half of the middle number and square it. So -1 squared is +1. All right? But if I add +1 there, I've got a -1 over here. Right? So I added 1 here, but I'm going to -1 over here, because my net result is I can't just add 1 for the fun of it. All right? If I add 1 to one part of the equation, I got to minus it out somewhere else. So let me just, this part now, x squared minus 2x plus 1 turns into x minus 1 times x minus 1. And now we have -15 minus 1 is -16. X minus 1 times x minus 1 is x minus 1 squared minus 16. Which, what do you know, looks like choice D. So I kind of gave you the non-technical way, how to eliminate answers. And for this one, I gave you how to actually get the question right. All right, keep studying. You're going to do better, I promise.